So in this lesson, we'll be looking at unit circle definitions. Now, a unit circle has its centre at the origin and a radius of 1. So if we draw a diagram of this, we'll draw up a set of axes, circle there with a centre at the origin, and the radius there of 1 unit. Now we're going to pick a point on our circle. We'll call that the point P there with the coordinates x, y. And if we join that P up to our origin, well, the length of that line we've just drawn will be 1 unit, because it's the radius of our circle. Now that line also forms this angle here with the positive side of our x-axis, so we'll label that angle as theta. And we're going to take our diagram, form ourselves a right-angled triangle there, using point P and the origin. Now if we take our point P as our basis here, the length of the base of our triangle will just be the x-coordinate for the point, or x units. And the height of our triangle, that'll just be our y-coordinate. Now looking at our triangle, we're going to find each of the trig ratios for our angle theta there, starting off with sine theta. We know that's opposite over hypotenuse, so our opposite there, y, our hypotenuse 1, gives us sine theta equals y over 1. Cos theta next is adjacent, so that's x over our hypotenuse 1. And then tan theta, well, that's our opposite, which is y, over our adjacent, which is x. All right, we're going to just note each of those at the top here, just so we can use them for some examples. Sine theta equals y over 1. Well, that 1 on the denominator, we don't need to worry about that, do we? Won't affect our answer, so sine theta equals y. Now, cos theta equals x on 1, exactly the same situation. So cos theta is just equal to x. And then tan theta, that's equal to y over x. Well, let's look at some examples here. We're going to start off looking at our point P there. Now that's a point in our first quadrant, or the first quarter of our number plane here. Now if we look at the coordinates of our point there, x, y, you can see that both x and y are positive values. So from the table above, if sine theta is equal to y, well that means that sine theta must be positive in that first quadrant. And if cos theta is equal to x, then cos theta is also positive. Now tan theta, that's y over x, so positive divided by another positive, well, tan theta is also positive. So looking at that, we can see all three of the trig ratios are positive in that first quadrant, so a big capital A there to show that all ratios are positive. Now let's look at another point. This time it's over here in our second quadrant. We look at those values for x and y. This time x is negative. Y is still positive though. So our sine theta to begin with, that's equal to y, so that would be positive in this quadrant. Cos theta though, that's equal to x, so that's going to be negative in this second quadrant. Tan theta, that's equal to y over x, so if we get a positive value and divide it by a negative value, well, we end up with a negative value there for tan theta. So looking at those three, we can see sine theta, that's the only positive ratio in this second quadrant, so big capital S here, to show that sine is positive. Now we can do the same thing here, moving down to angles in our third quadrant down there. And we won't go through the whole process, but we're going to put a big capital T there because tan is the only trig ratio that's positive in our third quadrant. And if we move over to our fourth quadrant down here, well, we'll put a big capital C there because cos is the only trig ratio that's positive in our fourth quadrant. Now, an easy way to remember this is using what's called all stations to central. We highlight each of those first letters there in each word. You can see we've got the A, the S, the T and the C. Easy way to remember which ratios are positive in each quadrant. Now we're going to consider some special cases here. We'll look at angles that are on the axes. So we'll label our angles on our diagram first of all. 0 degrees over here, up to 90, moving around 180 degrees, 270 degrees and 360 degrees. Now when theta is equal to 0 degrees, sine theta is equal to 0, cos theta is equal to 1 and tan theta is equal to 0. When theta is equal to 90 degrees, sine 90 degrees equals 1, cos of 90 equals 0 and tan of 90 is undefined. Because when we do our y over x we get a 0 in our denominator. Now when theta equals 180 degrees, sine of 180 is equal to 0, cos of 180 equals minus 1, and tan of 180 equals 0. Moving down now, when theta equals 270 degrees, sine 270, that's equal to -1, cos 270 equals 0, and tan 270, once again, is undefined. Now, when theta equals 360 degrees, should recognise these because they're exactly the same as for 0 degrees. Sine of 360 equals 0, cos of 360 degrees equals 1, and tan of 360 degrees equals 0. Now, let's look at an example here. We're asked, would the following trig ratios be positive or negative? We've got three ratios we'll be looking at. So we'll draw a diagram, our circle with our axes, and we'll put the angles on our diagram. 0 degrees, 90, 180, 270, and 360 degrees. Now we'll also put our A, S, T, and C, or all stations to central on the diagram. So sine 70 degrees first of all. So starting from 0, draw a line there marking 70 degrees. You can see quite clearly that's in that first or A quadrant. So all trig ratios are positive, so sine 70 will be positive. Cos 100 degrees next. So starting from 0, we'll go around here 100 degrees. Now that's in our second quadrant, or our S quadrant. So only sine is positive here, which means that cos of 100 would be negative. And lastly, tan of 210. Draw ourselves a line here, go all the way around 210 degrees. Now that's in our T or tan quadrant, so tan of 210 will be positive. Excellent work. That's our lesson on unit circle definitions finished. All the best as you work your way through the exercise.